Okay, today we're going to graph sine and cosine graphs, and we're going to start by doing the parent function, and then we're going to move into some that have been transformed. So let's start with our cosine theta. We talked a little bit about this one already, so we have seen this parent function. Remember the cosine of, I'm going to say this is 1 and this is -1 right here. So the tick marks are going by half on the y value just to see a better picture of this. So the cosine of 0 is 1. So this would be my first point as we go around that unit circle. Remember, the better you know the unit circle, the easier all this stuff becomes. And so the cosine of 0 is 1. The cosine of pi over 2 is 0. The cosine of pi is -1. The cosine of 3 pi over 2 is 0, and the cosine of 2 pi is 1. And so this is one full cycle of the cosine curve, and it should be a curve, so it should not have the jagged edges. So here is our first cycle. That's a period of 2 pi. From 0 to 2 pi, we have one full period of this cycle. From that point, it repeats, and so it would come back down like this, and it would continue that way. So that would continue the graph as it bounces back and forth between this -1 and 1. All right, we say that f of theta equals cosine of theta is an even function. In unit 1, we talked about even and odd functions. We said even, it has a reflective symmetry over the y-axis, which is the line x equals 0. All right, that's because if we folded right here, so here's my line of symmetry, the x equals 0, which is the y-axis. If we fold it in half, this side would fall right on top of this one. And if we kept going, this part would land right on top of this one. So it is symmetrical about that x equals 0 line. And so cosine of theta is an even function. All right, for our sine of theta, the sine of 0 is 0. The sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is -1. And the sine of 2 pi. Now, you could also do the rest of the angles in between there. So the sine of pi over 4 would be √2 over 2, which is about 7.707. So that's right about there. So you would see that curve happening there. But this is the first cycle of the sine curve. It too has a period of 2 pi. It's got the amplitude of 1, just like the cosine theta, and then it would repeat from that point. And so we would come over here and have this portion, and then that would move towards that way. And it would repeat forever. The sine of theta is an odd function. It has that rotational symmetry about the origin. So if we rotated it right here, this part would land right on top of this one. So if we twist there. So the sine function is an odd function. Now the cosine of theta is a transformation of the sine of theta. If you look at the graphs, we can shift sine of theta to the left and it will match up with the cosine of theta, or we can move the cosine to the right and it would land right on top of the sine of theta. For example, we can say that sine of theta plus pi over 2 is equal to the cosine of theta. So remember, this means to the left, pi over 2. And so if I move this to the left, pi over 2, this point would land right here. This point would land right here, and so on. Sorry, that point right there. And so it would be right on top of the cosine of theta. So they are transformations of each other. That does mean in a lot of cases when looking at a graph, you can write a, or in all cases, you can write a cosine equation or a sine equation for a graph and get those values. All right, so let's look at some of these transformations and let's go ahead and graph these. I'm going to go with the easiest way I think of graphing occurs. So we're going to start with f of x equals -4 sine x. So we have a reflection across the x-axis right here. We have a vertical dilation by 4 of the sine parent function. Now, last couple classes we spent talking about this 4 up in the front. That is the amplitude. So it is a vertical dilation. Remember, vertical dilation is when you do this, so that's affecting the amplitude in this trig function. There is no vertical translation here. We're not adding or subtracting anything to it, so our midline is going to stay right where the parent function 1 was, which was y equals 0. And then there's no b value here, so there's nothing changing this x, or sorry, in front of the x. So the period has not changed, so it's going to stay the same as our parent function, which is 2 pi. All right, so to graph it, I go ahead and graph the midline at y equals 0 with a dashed line, because that's not part of the graph. And then I use my amplitude of 4 to go up 4 from that midline and do another dashed line. This is going to be our top values where our maxes are found. And then I go down 4 and I again do a dashed line. That's where we're going to find all of our minimums. So let's go back up here to just see this graph real quick. What I've done is draw a line up here at the top of the amplitude because I see all of these max values are going to end up on that line. And then I drew a line at the bottom of our amplitude here where all the minimums are going to land. Same thing with the sign here. These are my max, these are my mins, and they're going to fall on those two lines where the amplitude is reached to the top and the bottom. All right, so now we go with our sine graph. And so with our sine graph, it starts at the midline. So my first point is right here if it has not moved to the left or right, so no phase shift. That's right here. The sine of 0 is 0. So there it is at my midline. And then it goes up to the top, down to the bottom. So it's increasing until here, and then it decreases until 3 pi over 2, and then it starts to increase again. All right, so right here on my graph, I've started at the midline. The sine curve has a period of 2 pi here, so I'm going to go to 2 pi, and I know that it's right back where it started. So there's my first point, there's my last point. On the sine graph, I know that in the middle of those 2 points, I am back at the midline, so I know that point is going to be there as well. Now, my sine curve goes up, then back down, and then to the end. But this has a negative. So instead of going up to this point, it is going to go down. It's reflected over that x-axis. So this portion reflects down here, and then the part that we had down here is going to reflect up here. So in between these 2 points, I'm going to be at the bottom, and in between these 2 points, I'm going to be at the top. So we have now just graphed one cycle, one period of this function. Once you have that first one, then you're just repeating from that point forward. So you would go to the 2 pi and 1 pi distance. And then in the middle of that, the top and the bottom, and we repeat. And so there is my graph. All right, we're going to try another one right here. This one is the cosine. I've got one extra transformation here. I've got this 2 on the bottom. And so I have a reflection across the x-axis, my amplitude change of 2, and then right here, this is the same thing as writing 1/2 times x. So keep that in mind. That is the b value. So here's my a value. Here is my b value. All right, so there's still nothing being added. There's no vertical transformation. So my midline is still at y equals 0. My amplitude, we just said, is 2. If you want to include the reflection on there, that would be -2 and -4 there. Amplitude is really just a distance, so most of the time we say it's in absolute values as a +4, but this would be a -4 here, so if you want to include that reflection there, you would see that if you're talking about the a value, it would be -4. So let me actually rewrite that as that. The amplitude is 4, the a value is -4. Same thing here. I like to say my amplitude is in absolute value bars because it is a distance. But the a value is -2 because it has that reflection. All right, so for the period, in the last units we learned that we take that 2 pi, which is from the parent function, and we divide it by this b value. So we're going to divide it by 1/2. I keep change multiply, or keep change do the reciprocal, and so 4 pi is my period. All right, so this one's a little bit weirder to graph on there, but we're still going to do the same thing. We're going to do our midline first. There it is. Then we're going to do our amplitude. So I'm going to go up 2, and this is where my max values are going to go. And I'm going to go down 2. And now we're ready to graph. So the cosine curve would start at the top. So this would be my first point, but it's got the reflection, so that's going to go down to the bottom. It does not move left or right, so it's going to start right there. Now this has a period of 4 pi. So this is 2 pi. I would have to go another 2 pi to be at the same exact value right there. So I'm just going to make a note of it there. But I know in between these 2 points, I would be at the top because my cosine curve looks like this. It starts up here, ends right here, and then in the middle, it's at the other extrema. So at 2 pi, it would be at the other extrema right there, because that would be halfway between 0 and 4 pi. I'm going to do the same thing on this side here, or you can think about it as the period is 4 pi, so this is 2 pi plus a 2 pi would make it 4 pi right there. There's one full cycle of the cosine curve. And then in between those 2 points, it would be at the midline. And so we get a graph that looks like this. All right. Let's look at a couple more with some more transformations. So here's this one with a vertical dilation or an amplitude change of 3. We've got a b value again of 2, and then we have an up 1. So since this has moved up 1, my midline is going to be at y equals 1. So my dashed line is going to be right here. We just said the amplitude is 3, so I'm going to go up 1, 2, 3. There we go. Now I'm ready to start. Oh, we got to come up with our period. So we're going to do 2 pi divided by that b value. And so the 2's cancel out and we get pi. So this one has a period of 1 pi. That means I need to get a full cycle in within 1 pi distance. So my sine starts at the midline. So this is my midline point. There's no phase shift on this one, no left or right movement. So I'm going to start right there. Now, I go 1 pi and it should be right back where it started, because that's what the period tells us. We're going to have everything happen between that 1 pi distance. In between these 2 points, I know I'm back at that midline, so I've got this point right here. Now my sine curve goes up, down, and then back to this point. So in between these 2 points, I'm going to be at the top, and in between these 2 points, I'm going to be at the bottom. And so here is one full cycle of that sine curve. From that point, it just repeats. So 2 more units, I'll be here. 2 more units, I'll be back. And we would do the same thing the other way. And so there's my full graph. On the quizzes or tests, you guys need to be able to graph at least 2 to 3 cycles for us to give you all of your points. All right, for our next one here, now we've got a little bit more transformation. So there's a couple of them here. Before I can get started with this one though, I do have to factor out this 2 because this is not in the transformational form. For it to be in the transformational form, there should be nothing in front of the x. It should be factored out. So I'm going to rewrite this with it factored out. So there is my factored out equation. That does not change the amplitude. It's 3. That's the number in the front. It does change the phase shift. If you don't do the factoring, you're going to say it went to the right pi, but it actually went to the right pi over 2. You must factor that out before you do the transformations. We also have this vertical translation of 1. So my midline is going to be at 1. So I'm going to start with my midline here at 1. We're going to do the top line 3 up from that because of the amplitude, and the bottom line down 3 because of the amplitude. All right. For the period, we take 2 pi and we divide it by 2 because that's my b value right there. And so the 2's cancel out, so the period is 1 pi. All right, we're ready to get started. This is the cosine graph, so it starts at the top. So we're going to start right here. Now I need to shift this to the right pi over 2 because of this right here. So I'm going to go to the right pi over 2, and that's going to be my first point. Now I use my period of pi to go 1 pi, and I know it's going to end right there. In between these two values, I'm going to be at the bottom, and then in between those, I'm in the midline. And so we have our first cycle right here of the cosine curve. From that point, it's just repeat. So I would go another pi, and another pi. In between those, I'm at the bottom. In between these, I'm at the bottom. And so there is our cosine curve. All right, we're going to use those skills to work backwards as well. It said write the equation of the following cosine curves, and it gives us the graph here. In this case, it said cosine, so we have to write a cosine equation. If it says sine, then you want to write a sine equation. Be careful for those details. Make sure you're looking at them to see it. All right, so to write these equations, it said it's going to be cosine, so I know I'm going to have that portion right there. What goes in front of the cosine is our amplitude, so that's the first thing I'm going to look at. We do that by finding our midline first. So we've got 1, 2, 3, 4, 5, and 6 units in total. So 3 units in either direction would be my midline. In this case, that's 0. And so then it went up 3 or down 3. So my amplitude is 3. All right. The next thing I need to do is think about my cosine curve. Well, cosine starts right at the top, and this is right at the top. So I know it hasn't moved left or right. I do need to check to see if there is a period change. Well, right here, it is going from here to here. It's kind of blurry where you're seeing there, but that's pi over 2 right there. So the period of this graph is pi over 2. Every pi over 2, I have a new cycle. So we said 2 pi over b gives me my period, and the period is pi over 2 there. We cross multiply. We divide by pi. And so my b value is 4. And so I'm going to have 4 theta right there. The midline was at 0, so I know I haven't added anything on top. So that's how you work backwards to make sure you have all the parts. Let's try that again right here. In this case, this has only 1 unit from the bottom to the top. So our amplitude is 1/2 because it's 1 unit the entire thing. So half from the middle up, half from the middle down. Again, we're doing the cosine graph, so I'm going to have a cosine there. We have to look at the period. So from here to here, I can see that the period is 1 pi. And so 2 pi over b is equal to 1 pi. So I can see b has to be 2 for that to happen. And so this would be 2 theta. I didn't put a left or right movement because this is still at the top, which is where cosine starts. And so I know I haven't moved to the left or right. I did, however, move down since my midline is no longer at y equals 0. My midline is right here at -1. So that is -1. All right, for this next one, it says write the equation of the following sine curve. Use a positive leading coefficient and the closest phase shift possible, left or right. All right, so here we go. In this case, they said sine curve, So I know I want to use the sine curve. You can make a cosine that will give you this graph. Just like up here, you can use a sine curve, but you want to look at those details when taking the test. All right, so our midline for this one is right here at -1. This is going to be the middle of our graph. It goes 2 up or 2 down. So my amplitude is 2. It said we want to use a positive leading coefficient, so I know I want to use the positive 2, not the reflection one. That's important because that helps me pick what point I'm going to start with on the left or the right. All right, so we know we're going to have some kind of transformation, left or right. We just said that the midline is at -1, so I can go ahead and put that part there. That's what's going to make my midline -1. All right, now we need to find the period of the graph. And so right here, I can see that it starts at the midline, goes up to the top, back to the midline, goes down, and it would come right back up right there. So that would be one full cycle. So I could see the period is 2 pi. Since that is the same as the parent function, I know there's no b value, so this is just theta. We did just say this is where it starts right here, though. This is not at 0, so I know there's a phase shift. It's moved to the right. So this moved to the right pi over 4. And so in order for it to move to the right pi over 4, we get theta minus pi over 4. Remember that minus tells you right from your transformations. If it was a plus, it would be going to the left. I use this point instead of this one right here because we could also say this one. But since the sine graph goes up, then I know for this one I would need that reflection. So if I had chosen to go to the left here, I would need a negative right here. And this said it wanted a positive leading coefficient, so this was the best one to go to. All right, we practiced a lot of graphing there. There's a lot to graphing, so make sure that you practice some so that you know where all of the parts come from.